Our next lesson will be about velocities. That means velocity as a vector. We can find there are typical velocities, like it can be relative velocity, or it can be velocity of a plane, velocity of a ship, velocity of, so anything can be written as a vector. We know velocity is a vector quantity. So let's see first relative velocity. What does it mean? So whenever I have, let's say an example, if there is a bus going this way at 85 kilometers per hour, and if there is a car going at 90 kilometers per hour, and if there is a train going the other way, let's see, the train is going to 80 kilometers per hour. So these are velocities seen by a person observing from helicopter up. These are the actual velocities. When you are in a helicopter, you see these velocities. But when we say relative, let's say if I say velocity of the car relative to the bus. So velocity of the car relative to the bus. It means I have to do velocity of the car, the first letter, take away velocity of the bus. Let's see, by convention we can always say, let's see here, if the west, let's take west as positive and east as negative. You can take anything you want. You can do the opposite one too, as far as you have the right convention here. You follow your convention, what you did here. East as negative and west as positive. So in this case, velocity of the car is 90 kilometers, 90, which means it's going east, so it should be negative. Negative 90. Take away velocity of the bus. The bus is going to east. It's negative 85, which is 90 plus negative 90 plus 185, which is negative 5 kilometers per, which means 5 kilometers per hour. Since it's negative, east. You feel like going to the east, 5 kilometers. If I have V of the train relative to the car, which means Vt minus Vc, which is velocity of the train is going west. West is positive, therefore it's 80. Take away velocity of the car going east, negative 90, which is 170 kilometers per hour. So if you can feel it, if in highway you are going to the opposite way, you feel like a very high speed. If you are passing a car on the same way, your speed looks like very small. That's practically what it is. Okay, let's see an example for a plane. A plane is steering at N50E, that means east of north, at an airspeed of 530 kilometers per hour. The wind is from. The wind is always, we write from. It's coming from west of north, 62 degrees, at 100 kilometers per hour. Find the ground speed and the direction of the plane. So before we say this one, first of all, when we say airspeed, airspeed means in still air. Still air. So what we have is always we have airspeed plus the wind speed, triangle of flow. So this plus that will be the resultant. Our resultant will be the ground speed. Ground speed. The ground speed. So we always say find the ground speed means find the actual velocity of the plane. So the ground speed, we can find the direction always. The direction can be called course or it can be called track. So the things are given, and then angles are given like n 62 degrees west, means 62 degrees west of north. Sometimes we say bearing. Just we'll not use bearing in this example here, but bearing of. Whenever we say bearing, we always have 3 digits, 0, 62. This is a bearing of 62 means. Bearing always means from north, counterclockwise from north, clockwise from north. This one is clockwise, 60 degrees. So it's always from north. So coming here, starting at the north, always going counterclockwise. So that means, let's say bearing of 182 degrees. It would be 100. This is 180, 182 here. So the bearing always from north, so we'll use only west of north. This kind of works. So let's take the diagram for this one here. Okay. Let's first do the north. This is the north. Okay, east, south, west. So what we say is, whenever we draw this one, it must be approximately proportionally. If like we have 500 series and 100, this means this is almost 5 times more than this one here. 5 times 100 is 500 series. So we say, let's see, it is 50 east of north, 50 degrees. This is north. East of north 50 will means from here okay, let's say this is 50 degrees. And then we have the wind is coming from means going the other way. It's coming from 62 degrees west of north. 62 degrees west of north. This is 62 degrees. It's coming from here, but it goes to the other side. So this is the wind. So this is W. Let's call this one U. Therefore now the resultant will be, we make parallelogram with this one here. Parallelogram of this. So this will be my resultant, which is the ground speed, the ground force, the ground vector. So this is W. Okay, so this angle's here, so it's 50. So we have to find, since this is 62 degrees, this is X. Let's say if I take this one here, 62, this will be 28 degrees. So now we have to find U plus W, the resultant. So to find this, always the resultant, we use the cosine law. Square is equal to the cosine law, which is absolute value of U square. Okay, let's see, U square plus absolute value of W square minus 2 times U W cosine of my angle. So cosine of my angle, now this is the angle I'm looking for. So the angle I'm looking is this one here. So this angle here will be, let's say, how much would be this angle here? This is a parallelogram. This is this angle here. If this is 50, from here to here will be 40, which is left. 40 plus 28 is 68. Therefore, it is a parallelogram. Since this is 68 degrees, 180 minus 68, this angle will be 112 degrees. Will be 112. So now we use u square, which is 530 square, plus 100 square, minus 2 times 530 times 100 times cosine of 112 degrees. All this will be equal to 330, 608. Therefore, u plus w, the magnitude, will be the square root of that. The square root of that will be approximately 575 kilometers per hour. So now we find the direction of this. We have to find the direction. We can find the direction from north or from whatever south or west here. So let's say this angle here is theta, because we know from here to here is 40, but we want to find the direction, either this angle or this angle here. To find this angle here, I can use sine law, which is sine of theta over 100 is equal to sine of 112 over 575. Sine of 112 over 175. So sine theta will be 100 times sine of 112 degrees divided by 575, which is 0.161249. Therefore, my angle will be 9.28 degrees. So since this angle is 9.28 degrees and this angle is 50 already, so from here to here will be 50 plus, so 50 plus 928 is 59.28 degrees. So what do we say? It is, I write the magnitude first, 575 kilometers per hour. Then from north we have 59.28 degrees, which is east of north. This will be my final answer.